Hello, my name is Jeff Orrock. I'm the meteorologist in charge at the National Weather Service office in Wakefield, Virginia. Today we're going to spend just a few minutes talking about the outlook for the upcoming hurricane season, talk about hurricanes in general, and a few more things that you need to know about all the different threats that hurricanes bring to Virginia, Maryland, and North Carolina. So just an introduction to the National Weather Service office in Wakefield. We provide all the forecasts and warnings for Central Virginia, including the Richmond Metro, Southeastern Virginia for Hampton Roads, Northeast North Carolina, including Elizabeth City and locations north of the Albemarle Sound, as well as all of the Eastern Shore, including the Maryland Eastern Shore, up around Cambridge, Ocean City, and Salisbury, Maryland. All in all, it's about 66 different counties and independent cities that we serve. We also do forecasts and warnings for the Chesapeake Bay, the tidal rivers of the Rappahannock, York, and James River, as well as the ocean waters from Ocean City, Maryland, all the way down to Currituck Beach Light. Our operations are 24/7, 365 days a year, so there's always forecasters in the office working on all different types of forecasts and warning services on both the land as well as out in the ocean and the marine. So real quickly, we'll talk about a hurricane. And of course, one of the most notable things about hurricanes is always the eye, the satellite looking right down the eye here of Hurricane Harvey. It was a major hurricane working its way towards the Texas coast. You see a very deep eye with very intense rotation. The eye wall is surrounded by thunderstorms, and that's really helping drive all of the wind. And really, in its essence, what hurricanes are, they're really massive heat engines. They really rely on very, very warm water temperatures, usually about 80 to 82-degree seawater. And so as the ocean gets warm and sometimes the atmosphere gets unstable, we start to see clusters of thunderstorms that start to develop out over the Atlantic, in the Gulf of Mexico, and the Caribbean Sea. And so as those clusters of thunderstorms develop, you get a lot of rising motion, the thunderstorms being driven by the hot air and the hot water, and that's the moisture in the fuel source. So as all these thunderstorms develop, sometimes they'll start to develop in clusters. And as they cluster, they'll start to actually organize and they'll start to get a little rotation. And so the area of thunderstorms will start to gradually spin. And at that point, it's known as a tropical depression, where you have a cluster of storms being driven by a lot of heat and instability, and the clusters of thunderstorms start to spin and rotate. As they continue to organize and they start to rotate around each other faster and faster, once the wind speeds get up to around 39 miles per hour, that's when the storm actually gets its name, and it's classified as a tropical storm at that point. As the storm system maybe continues to intensify and grow, once that tropical storm reaches wind speeds of 74 miles per hour, now the system is upgraded to a hurricane. It maintains the same name, of course, it just goes from a tropical storm up to a hurricane once it jumps from 39 miles per hour up to about 74 miles per hour. Hurricanes are fairly large systems. They're usually a couple hundred miles across. The eye wall itself can be anywhere from a real small eye would only be about 10 miles across. A larger eye may be around 30 miles to even 50 miles in a very large system. So hurricanes can vary in intensity as well as in the actual size and how large of an area the hurricanes are impacting. Speaking of that, the way that we classify hurricanes is really what's known as the Saffir-Simpson wind scale. It was developed by a gentleman by the name of Herb Saffir and Robert Simpson. They worked together and came up with a system to classify hurricanes based on their wind intensity and also how much damage they're going to cause, basically from the wind. Category 1 hurricane starts at 74 miles per hour, as we mentioned, and goes up to about 95 miles per hour. Once wind speeds reach 96, that's when it reaches a Category 2 intensity. At 111 mile per hour wind, we recognize it as a Category 3 hurricane, and that's known as a major hurricane. So a major hurricane is classified as a Category 3, 4, or 5 hurricane. At 111 to 129 miles per hour, it is a Cat 3. Category 4 starts at 130 miles per hour and goes up to 156, and then Category 5 way up there at 157 mile per hour wind or greater. So again, this is a wind scale, and it kind of gives us an idea of how intense the hurricane is just based off of the winds alone. And that's why we classify this as the Saffir-Simpson hurricane wind scale. We'll talk more about wind here a little bit later. Climatologically, looking at how many tropical systems have actually impacted really the mid-Atlantic. And so this is tracking all tropical systems, tropical storms and hurricanes combined, that have tracked within 100 miles of Norfolk, Virginia. And really gets to the point you can't even see the map. So the bottom line is tropical systems are just part of our history. It's part of our climatology. So we just have to deal with them with some frequency. Looking at all the different tropical systems that have at least crossed the Virginia border, you see that really all parts of the state have seen tropical activity at one point or another. You do obviously see more activity once you get towards the Tidewater of Virginia and southeastern Virginia as hurricanes are approaching from the south. But really, no part of the state is immune from a hurricane's wind or flooding. So focus back in on the eastern part of the state where most of our stronger systems impact. This is looking at just hurricanes alone that have tracked within about 100 nautical miles of Norfolk. So you still see, just looking at what storms that have 74 miles per hour or greater coming within 100 miles of Norfolk, you still see a lot of hurricanes that come up here and have threatened us in the past. We do have a kind of this classic, track where the storm systems come at us from the south, and what they'll do is they'll kind of gradually start to recurve. They'll hit North Carolina, maybe bump us, and then go back out to sea. And you also see another common track that comes out of the Gulf of Mexico or off the east coast of Florida, and we get these storm systems that come at us from the southwest, and we still see impacts. If you think back to Hurricane Matthew a few years ago, it actually made landfall all the way back here on the Gulf Coast, swung across the southeast and parts of Tennessee and North Carolina, and eventually moved across Virginia. And even when it came through here, we still saw lots of heavy rain and some very intense winds of over 50 to even 75 plus miles per hour as the system came over us as a remnant system. So we always have to keep an eye on systems that are approaching us, really whether they're coming in from the ocean or even if they're coming at us from land. We always have to keep a close eye and watch what's going on. Now, just trying to narrow this down to look at how many hurricanes have actually come into the Chesapeake Bay, how many storms have really come in here and caused us a lot of issues, a lot of high wind, a lot of tidal surge, a lot of bad storm surge flooding. This gets us into a lot of what we call our record storms for Virginia. And you see some names that jump off the list here. You see Hurricane Floyd that hit back in 1999, made landfall down here along near the Crystal Coast of North Carolina, moved straight north, passed near Richmond, and actually brought us a lot of heavy rain, a lot of storm surge, was a very bad system, had some record flooding for its time, and was a very powerful system with big impacts here in the Carolinas and in Virginia. Hurricane Isabel is another notable storm. It struck in 2003. Some folks that have been here for a while will remember that storm for sure. That storm system came in right south of Ocracoke, North Carolina, and it moved straight inland. And it was almost a Category 3 hurricane at landfall. And it continued to pass inland, passed actually over western Virginia. But the problem was all of the eastern part of Virginia, Hampton Roads, and the tidal rivers stayed on the right side of the storm, where the wind was the strongest, and all of that wind pushed the storm surge in from the ocean into the Chesapeake Bay. And for a lot of us, around today, this has been some of the higher storm surges that we've seen was from Hurricane Isabel back in about 2003. There was another event back in 2009. It was a combination of Hurricane Ida and a nor'easter, and in some areas we call it Norida. That had some higher storm surge values. So it just depends upon where you were. But Isabel was one of those top-end storms that brought us a lot of high wind, a lot of heavy rainfall flooding, and a lot of storm surge. The other storm, which is not labeled, but it's in the display here, is actually Hurricane Irene, and it made landfall in 2011, again over North Carolina, curved up near Elizabeth City and tracked right over Virginia Beach and Sandbridge, and then exited the coast. And that was one of the more recent, I'd say, more intense tropical systems that we've experienced here, and that was back in 2011. The storm that's actually shown here in bold is the 1933 hurricane. It is still the record-setting storm for the region. For most areas, it's the record storm surge. It's the highest water levels that we've ever seen in the Chesapeake Bay and a lot of the tidal rivers. It came into really almost Nag's Head and Kitty Hawk. Notice how it was a very atypical approach. It came in straight from the ocean, struck the Outer Banks, and then went right over Chesapeake and Norfolk, and then eventually up east of Richmond. That is a worst case strike for us, a hurricane coming straight in and staying to our south, because with the counterclockwise wind, it pushes all of the wind and the storm surge right into the Chesapeake Bay, and we'll get phenomenal, incredible storm surge values, really like no one's ever seen before. So a repeat of this system is one of our worst case scenarios. Any type of hurricane that's going to come at us from the southeast and right up near the Chesapeake Bay is a horrible concern for us, and something that we have to take very seriously and be prepared for when it does come. So how often do we see a hurricane here in the mid-Atlantic? So this is what we call return frequency. So typically the Outer Banks, you look at Cape Hatteras, they'll see a hurricane, at least coming in their proximity about every 5 years. They'll be dealing with a hurricane that's at least getting fairly close to the Outer Banks and Cape Hatteras. You see, by the time you get up to Nag's Head and Kitty Hawk, those probabilities drop down to about every 7 years. So that's still pretty frequent. For us up here in Virginia Beach and Norfolk and parts of Portsmouth, the return frequency is about every 13 years that we'll see a hurricane actually coming up and really threatening us as far as getting pretty close to us. And so what you see there is there's a very high frequency of hurricanes that will pass near the Outer Banks, but they'll kind of want to recurve and then go back out to sea. And sometimes we get spared that way. But every so often they'll come at us straight from the south, or they'll come at us from the southeast. And they'll still maintain hurricane conditions even once they get close to the North Carolina-Virginia border. So don't let that kind of give you a false sense of security. One thing I really take away from this is that one of the hottest zones for hurricane activity along the entire East Coast and Gulf of Mexico is the Outer Banks of North Carolina. So the Outer Banks of North Carolina is like Hurricane Alley, and you got to think of it about that way. And so we sometimes could be dealing with hurricane threats multiple times a year, because honestly, that's just the way hurricanes track. A lot of hurricanes can potentially track very close to the Outer Banks. And if they're tracking close to the Outer Banks, they're a threat for us here in southeastern and even central Virginia and northeast North Carolina. So that's why we talk about it so much. It's a high return frequency, and we deal with it a lot more than other places along the East Coast and the Gulf of Mexico. So how does hurricane season shake out by month? Well, typically June and July are both very quiet. You see here in June, just like we had with Tropical Storm Arthur this year, typically early season storms will form very close to the continental U.S. Typically they're not major storms. They're usually the weaker variety storms. And they'll usually kind of track up along the East Coast, just like Arthur did. Usually the impacts are somewhat minimal. We get a little bit of heavy rain, a little bit of wind, but they're not usually our big type of hurricanes. They bring us a lot of issues and devastation. July is not much different than June. You do start to see more activity starting to develop further out into the Atlantic. Still, most of the development is in the Gulf of Mexico or right off the southeastern U.S. So typically June and July aren't that active for hurricane activity. August and September is a whole different show. By the time we get into August, you notice the hurricane activity really starts to increase, and by September, you're starting to see really a lot of those longer track storms, the storms that are residing over that warm water much longer. They're able to intensify, to grow from category 1 to 3, maybe even up to 5, then they may weaken back to a 3, and then go to a 4. They're just going through long life cycle evolutions because they're able to live a long time because they're tracking long distances over very, very warm water. So August and September get us into the peak of hurricane season. Now, we can't drop our guard in October either. Notice how much hurricane activity we can actually see along the eastern seaboard, and not only its frequency. You can actually see a fair number of tropical systems, especially into the first 2 weeks of October. And so we have seen some very devastating storms in the October month. Hurricane Hazel in 1954 is one of their benchmark record storms. It hit in mid-October of 1954, and it was a devastating hurricane. So we don't drop our guard in October. Usually by the time we get into late October, the hurricane season is waning very quickly. Things are getting colder, and we're losing the heat source that hurricanes need. So by the time you get into November, obviously hurricane season and tropical activity is really waning pretty quickly. But October, we got to watch those first 2 weeks in October every year to see if this activity may keep going and pose as a threat. So this just shows us how it shakes out throughout the entire year, both hurricanes and tropical storms combined. So again, we talked about how June and July are usually fairly quiet. And by the time you get into about mid-August is usually when things start warming up and the hurricane activity really turns on. The absolute peak of hurricane season, right there about middle of September, about September 10th, maybe about September 15th. But that middle part of September, that's the peak of our hurricane season. Notice how it kind of drags out and kind of lingers even into October, and that's what we just talked about. You see how the hurricane activity and tropical storm activity can still be somewhat elevated as we get through the early parts of October, but by the time we get into November, usually the activity is falling off very quickly and things are getting a lot cooler. One thing I really want to note that's really been really an asset, I think, to all of us is really how accurate hurricane prediction has started to become, especially when we're tracking where the storm is going to go. And so really now, once you're within about 24 hours of a hurricane actually coming up here and maybe impacting Virginia, North Carolina, the hurricane accuracy is now better than 50 miles. So we're really narrowing down the portion of the coast and those cities that are going to be most impacted by the hurricane. So at 24 hours, they can actually now forecast within probably about maybe a 30 to 40 mile area of where that hurricane is going to hit. What's even better is that 2 days out, so this is 2 days before the storm's going to get here, hurricane's way down probably in the Bahamas. We're almost just at about maybe, let's say about 60 to 70 miles. So we're able to still narrow down what part of the coast and what areas are going to be most impacted. And this is when a lot of our evacuation decisions and things that are folks really having to kind of start taking a lot of precautions, preparing to leave, getting their houses ready. And so we're really able to narrow it down of where the storm's going to go. And remember, if we say the air is about, let's say, 60 to 70 miles, remember the eye of the hurricane itself is anywhere from probably 10 to 20 miles, maybe 30 miles across, and the hurricane's maybe a couple hundred miles across. So you were really narrowing down where is that thing going to actually make landfall, and then the zone around that's going to be impacted. So that's been amazing. Even at 3 days out, when the hurricane is sitting way out in the Atlantic Ocean, we're within 100 miles of where that storm is going to track and where it's going to hit. So at 3 days, we kind of a broad scope of where the coast is, what part of the coast is going to get hit, but we're still kind of have a good sense for what states are going to be the most impacted. Once you get within that 48-hour window, things start narrowing down even more, and then by the time we get within 24, we're just about zeroed in on where the hurricane is going to track. So you can see how the improvement in hurricane track forecasting has really improved. And really, if you go back to about 1999 and 2000 with Hurricane Floyd, and even 2003 with Isabel, you can kind of see on this red line, the orange line, you can see how much the track forecasting has improved, really since the 1990s and even the early 2000s. So very impressive. It really helps us as a local National Weather Service offices fine-tune our forecast and try to tell you, how much wind do you expect? How much rainfall are we going to experience? And then how bad is the storm surge going to be? What areas are going to flood? How bad and when? So the more accurate we're able to predict where the hurricane's going to go, the better forecast we're going to be able to provide to help you prepare for the storm. So what do you need to know about this upcoming hurricane season? You see the names there on the left-hand side. Hurricane Arthur has already been checked off the list, or excuse me, Tropical Storm Arthur has been checked off the list. You see we have Bertha, Cristobal, Dolly, Edward. Some of these names have been used in the past. The names do get recycled every few years. If the hurricane is big enough or causes enough of a devastation, the name will be retired. But you will notice that some of these names have kind of been resurrected from past hurricanes if some of these look familiar to you. So here's what a lot of folks want to know. What do we expect this hurricane season? And honestly, it's not the best news. Right now, the way things are shaping up, the way the El Nino is setting up, or the La Nina in the Pacific, the sea surface temperatures in the Atlantic, how we predict the weather patterns to be behaving over the Atlantic and the Gulf and the Caribbean Sea, everything is pointing to the fact that looks like we are headed into what is potentially an active hurricane season. So shaking down the numbers, forecasting anywhere from about 13 to 19 named storms out there, about 6 to 10 hurricanes, so that's storms with winds of 74 miles per hour or greater, and major hurricanes of category 3 or greater, anywhere from 3 to 6 of those type of hurricanes, the big ones out there. So what's normal? So in a normal year, you'd have maybe about 12 named storms out there, maybe 5 to 6 hurricanes, and about 2 to 3 major hurricanes. Those are your normal numbers. So these numbers are quite a bit above what we would typically normally see out there in the Atlantic and the Gulf of Mexico. So what's the chances that we're going to see a busy season? Well, unfortunately, based on everything we're seeing right now in the climate weather patterns and in the ocean temperatures, it's at least about a 60% probability that it's going to be above normal, and maybe only a 10% chance that it's going to be below normal. So the bad news is that if you combine the probability of a normal season and an above normal season, there's a 90% probability it's going to be normal or at least pretty active in the Atlantic. So that's not great news for this season. It doesn't necessarily equate to if we'll be hit or not. That just depends upon, how the storms are tracking when they get real active. So in any year, we have to be prepared, because some years we don't see very much hurricane activity, and we see absolute devastating storms. So you only have maybe 2 or 3 hurricanes, but one of those is a major hurricane that comes in and devastates a major city. In other years, we've seen the Atlantic be very active and a lot of hurricanes, but then none of them made landfall. So there's not a big correlation between how many storms are out there in the Atlantic and how many actually make landfall. The main thing is we have to be prepared in every year and every season, and especially this year when we know things could be different when it comes to sheltering, our ability to prepare, and then evacuation. So definitely want to be thinking about hurricane season as we head through the months of June and July. So our different threats that come with hurricanes, there's a pretty good host of threats that we deal with. Storm surge we'll talk about. That's one of the biggest issues that we deal with. We have a lot of people, a lot of homes, a lot of businesses and infrastructure near the coast and along tidal rivers. And that becomes a huge threat to us here in Virginia, all the way from the Potomac River in Washington, D.C., down to Hampton Roads, Virginia Beach, Norfolk. Even smaller towns like Suffolk and Smithfield and Tappahannock have huge storm surge issues. And we'll talk more about that. Just the wind itself, the wind that's in the hurricane, obviously that causes a lot of damage. Inland flooding. So this is really where we can get the whole state involved in some of these bigger storms where, okay, the hurricane comes up here, maybe it's got 70 mile per hour, 75 mile per hour wind in it. We're getting storm surge, but then it also drops anywhere from 15 to 20 inches of rain. And now we've got heavy rain in Richmond or out towards Lynchburg and Roanoke or up near Northern Virginia near Washington, D.C. and Fairfax. And so when you start getting these heavy amounts of rainfall, you're going to have a lot of flooding. And what's one thing we always say with these tropical systems, when you hear hurricane or tropical storm, think flooding. Somebody's probably going to have a flood. It's just a matter of how bad is it going to be? How much rainfall are we going to receive over what period of time? So when you hear hurricane, start thinking flooding. Tornadoes, we actually also see tornadoes embedded in these hurricanes and the spiral bands as they pivot around, especially the north and the east side of the hurricane. That's typically where you start to see some of these tornadoes forming. You think back to when Hurricane Florence hit North Carolina and it basically drug across North Carolina for a week. But by the time it started moving up the mountains of Virginia, the remnants part of the system, we had a tornado outbreak in central Virginia in Richmond. I think we had almost about 9 to 11 tornado touchdowns in just an hour and a half. And that was from a remnant tropical system. And some of those tornadoes got fairly intense, destroyed a number of buildings and homes, and even caused a couple of fatalities. The other threat that we don't think about sometimes quite as much with tropical systems and hurricanes are really waves and rip currents. And even when tropical systems are passing well off the coast, and maybe it's a nice sunny day along the beach, those tropical systems kick up the waves. And when those waves increase, so does the dangerous surf and the rip currents. So sometimes it just looks like the waves may be fun to play in. We have some nice waves breaking along the coast. It's not particularly rough, but as those waves come up and break on the beach, that water goes back to the ocean and it starts to develop pretty intense rip currents. And we forecast those as well. So we're always cognizant when we have tropical systems offshore, how it could impact our beaches and make things a little bit more dangerous for swimmers. So what most people think about when they hear about hurricanes is the wind. It's natural. You see videos and pictures of it, things blowing around, roofs coming off of buildings. So most people think about the wind. And the wind can be very damaging. One of the safety rules we say is you can hide from the wind. That if you're riding a hurricane out in a shelter, or if you're riding it out at home, and you're in a fairly safe area that doesn't flood, and the wind speeds aren't going to be particularly too strong, you treat it like a tornado. When the wind really starts to blow hard outside, you can seek shelter in the interior room of the house, hiding from trees that may fall down, things that might hit the house. Now, you can get to a point where the wind becomes too strong to even stay sheltered in well-built homes. But typically, Category 1, Category 2 hurricanes, while they're very dangerous, and they can cause very big storm surge, a lot of times, our well-built structures and some of our better shelters can actually handle that type of wind. You want to take it seriously. You want to board up windows. You want to keep the wind outside as long as you can. You never want wind to get inside of a building. You want to make sure your garage doors are reinforced. You want to be able to hunker down and take shelter. But then once we get to about Category 3 hurricane, everything starts to change a little bit. And notice that by the time we get to Category 3 here, it mentions that devastating damage will occur. We go from it being dangerous and having some damage, all of a sudden it's just absolute devastation at Category 3. So why is that? Why is it a major hurricane we say the damage is just the wind damage is going to be devastating? Well, If you look here on the scale on the right-hand side, this is the wind speed in miles per hour. And this is the damage potential. It has to do with how much force is being applied to buildings and structures. So the bottom line here is when you have a Category 1 hurricane, if we assume that's a force of 1, by the time we get up to a Category 3, where we say there's going to be devastating damage, the force factor and the damage factor on buildings is about 30 times what that is of a Category 1 hurricane. So why is that? If I just jump up from 74 miles per hour, let's say to about 111 to 115, why is the damage being increased by a factor of 30? Well, the reason is because moving wind is like moving water. Wind has weight to it, actually. The air around us, it actually has weight. And so once the wind starts to blow and gets momentum, it produces a force. And so as you increase the wind speed, the forces that wind applies on our homes and businesses goes up exponentially. It's not a one-to-one correlation. It's actually an exponential increase. So that's why a Category 3 hurricane can do so much more wind damage than, say, a Category 1. It's an exponential factor that causes damage to our buildings and our homes. So just keep that in mind. But again, assess your threats, assess the trees around your house. Are you in danger from falling trees? Are you in danger from maybe things flying around and hitting your house? If you live in a mobile homes are not designed to really handle any hurricane force winds. So any type of mobile home, you want to make sure that you've got someplace better to go. If it's really well-built construction, that's not at danger from being struck by trees, and it's a lower-end hurricane, you can probably use that house as a lifeboat and just ride out the storm, taking the necessary precautions and hiding from the wind. But Category 3, with that type of force, that's when even the well-built structures will start to become compromised. So again, we talked about when you hear about a tropical system, you hear about a hurricane, you got to think water, think flooding, and that's really going to be what's going to affect a very large area, whether it's storm surge or whether it's rainfall. You get a lot of flooding from these storms, and they bring a lot of water. So the main thing we say for the storm surge area is we said hide from the wind, but run from the water. You cannot hide from storm surge. When that ocean and the rivers and the bay, they come up and the waves are breaking and that water's spreading inland, your house you cannot hide in your house from the water. The water will find its way in and start to basically knock the houses down and move houses. So you've got to get away from the water. And we've all seen pictures with folks on rooftops trying to be picked off by helicopters and rescued. So realize you cannot hide from water. You have to get away from storm surge zones and areas that are going to flood. So when a hurricane comes in, the combination of the wind and maybe a little bit of low pressure just drives that water right in here. And we have some very unique flood problems here along our coast, especially in the Chesapeake Bay. All of our tidal rivers like the Elizabeth River, James River, even the smaller ones like Back Bay and Broad Bay here across parts of Hampton Roads, the York River, the Rappahannock River. And then you get on the eastern shore, we have all these little nooks and crannies along the eastern shore in Saxes and in Crisfield and Onancock, where the water can really get driven in there, and it's shallow. So when the water goes in, it just has to go nowhere. It's nowhere but up and inland. And so a lot of our tidal rivers can be really bad for storm surge. And I'll actually show you an example of that here in a minute. When it comes to hurricane deaths, and you hate to talk about hurricane fatalities, but any kind of big system that comes in, you end up with fatalities. And so we look at where do we lose people in hurricanes when things do go wrong? And it's mostly storm surge. About 50% of all of the hurricane-related fatalities is really along the coast or in storm surge zones. And it may not be along the immediate coast. Could be Norfolk, could be Smithfield, could be up in towards Surrey. It could be over at Hampton or up in Pocosin. So this isn't just a coastal issue. It's anywhere you can get storm surge and the rivers coming up. So even all the way up to Colonial Beach and Tappahannock, this can become a big, big problem. The other big factor is rainfall, and this actually is also flooding. When we say rain, it's really the flooding that's coming from the rainfall. And so we get the intense rainfall, we get a lot of heavy rain, we get a lot of flooding. Folks end up driving around in that. Most of our flood fatalities occur in vehicles. That's why we say turn around, don't drown. So it's mainly water. When you think about what's causing our problems and what really causes our fatalities and hurricanes, the bottom line is it's mostly water. It's either the storm surge or it's the heavy rainfall. And when you get both of those in one system, we can have a lot of problems. When you have something like Hurricane Floyd or Isabel, you get a lot of both, a lot of storm surge and a lot of rain. Just showing some pictures of the type of surge damage that we can see here, especially even in the Chesapeake Bay, not just along the coast. These are actually pictures from Hurricane Isabel, and you can see the damage there at Jordan Point Marina with the devastation. You can see how much the wave action is actually taking away and scouring the shoreline and really taking property there near Gloucester. And of course, that's a building that was gutted by waves. That's actually wave action that came up near Tappahannock. So you have the storm surge combined with breaking waves, and you can see how it devastated the building. I mean, water is very, very heavy, and when it's moving and you have breaking waves, it's going to push things out of the way and destroy objects and buildings. So storm surge and the waves on top of that storm surge are incredibly dangerous, and just some really interesting examples that show the power of storm surge and the power of water. So what's some of our worst case scenarios as far as storm surge? And one of the things we hear a lot is the fact that, we hear people that have been here a long time, including myself, growing up here. And you hear a lot of people saying that, well, I've been through, 2 or 3 hurricanes. I've never had a problem, never had any storm surge issues here. I've never had, flooding. The bottom line is every hurricane is different. Just because that one didn't impact you doesn't mean the next one will not. Every storm is absolutely, completely unique. And the areas that get hit and get the most devastated change on how that hurricane behaves. Just to kind of show an extreme example of this, these are showing storm surge projections for different category storm, for the same category storm. So this is a Category 3 hurricane that you see here. In the first image here on the far left, it's a Category 3 hurricane moving straight north. So the hurricane's coming at us from the south, moving north. And you can see that the water level's getting up to about 8 to 9, even 10 feet. That's some pretty bad surge, and that's because it's a Category 3 hurricane. But you see anywhere from 8 to 10 feet of storm surge. Now change the storm direction and bring it in from the southeast. So instead of the hurricane moving, straight north, now it's going to move from the southeast. And now all of a sudden those storm surge values go up to about 11 to 12 feet. So you've gone up from maybe 8 to 10 to 11 to 12 feet. And you guys know just a foot of water around here makes a huge difference. Bring the same storm, same intensity hurricane, and now instead of it coming at us from the pure southeast, now it just comes in from the east-southeast. It's just a slight change in direction of how it hits. And now all of a sudden the storm surge values are anywhere from 12, even getting up to 14 feet in some places here in the western part where it's getting into the pink. So we went from 8 to 9 upwards to anywhere from 13 to maybe 14 feet of water. I mean, and that's vertical elevation. So same hurricane, it's just hitting us at a different angle. So the main things we have to watch with a hurricane is how intense is it going to be, how big is the wind field, and then what's its angle of approach. And its angle of approach is one of the most important parts when it comes to storm surge and who's going to get the really bad storm surge and maybe who gets spared. It all has to do with how the hurricane hits us and how big it is when it gets here. And that's why every single one of these storms is different. So just be aware of that. This is actually showing you how powerful storm surge is along the coast during Hurricane Sandy, and you can see all these houses that have been lifted and carried from the ocean front and really pushed many blocks inland. Houses have been knocked off their piers and off their foundations and just pushed inland purely by the storm surge and really by the very devastating wave action. Now, for all of us here in Virginia and North Carolina as well, we promote Know Your Zone. And so emergency management has worked with the National Hurricane Center and the storm surge projections from different hurricanes and really identify the different zones, A, B, C, and D. And if you live in those zones, then you may be asked to evacuate depending on the hurricane's approach and how the storm hits us. In Virginia, there's a website right here, Virginia Emergency Management. You can go to the evacuation zone lookup website. North Carolina has something very similar. You can just Google it, but it's Know Your Zone. And so if you live anywhere in a coastal or tidal area, you definitely want to check this out and you want to know what zone you live in. When the order comes and maybe they're evacuating zone A and zone B, you need to know if you live in one of those zones or are close to one of those zones. Now, we talked about rainfall. I just want to kind of show some examples here of how dangerous a rainfall can be. And it's another part of the storm that we forecast and really try to fine tune. and realize that, even with the hurricane tracks in this example here, this is Hurricane Irene tracking along the coast when in the white line here. Notice where all the heavy rainfall fell. All the heavy rainfall actually fell to the west of the hurricane and actually fell well inland. So even though the track stayed off the coast for the most part here in Virginia, went across Sandbridge and back out in the ocean, look at all the heavy rain that we saw really up the peninsulas and even into parts of the Tidewater in North Carolina. So huge amounts of rainfall. Hurricane Floyd, very, very similar. Hurricane kind of tracked here over the eastern part of the state, and you can see all the heavy, devastating rainfall that actually occurred inland to the what we say the left of the track. So the rainfall can be displaced from the track. In fact, here's Hurricane Matthew back in I want to say this was 2016, and you can kind of see here how the hurricane recurved along the coast. And even though it never came up into Virginia, it actually stayed even southeast of Cape Hatteras. Look at how much rainfall we experienced over southeast Virginia. And in fact, some locations picked up 15 to 20 inches of rain from Hurricane Matthew, even though it never even got close to Virginia. The problem was that through all that precipitation to the north, it combined with a cold front, and we became the focus for very, very heavy rain. So we have to be very careful and recognize the fact that the hurricane doesn't have to actually come near us to actually cause us a lot of problems. This caused devastating flooding in parts of Chesapeake, especially Virginia Beach and Suffolk, where we experienced 15 to 20 inches of rain over really a very, very short period of time. And when you talk about rainfall, again, it's water. You can't hide from it. It comes in our homes. It causes a lot of devastation. We tell folks, never drive through water. But floods can be very, very devastating, and you cannot run from them. The best thing to do is to try to get out of the area and deal with it the best you can. And again, this just shows you examples of floods and when floods come into our homes and our businesses, how devastating they can really be. They're very devastating events. They're also very emotional events because you do have so much devastation and so much loss and ruin. But this just shows you examples of what it looks like when floodwaters really come in and start to cause us some serious problems. Also to infrastructure, and this also becomes dangerous for driving. When you have rushing water and floods, it's very efficient at basically undermining the roads, blowing out bridges, causing sinkholes, and so this also becomes very dangerous when folks are driving around. It's also very dangerous at night. Floods are always exponentially dangerous at night, where you can't recognize how deep the water is. Maybe a road's washed out and you don't see it until too late, till it illuminates by the headlights. So driving at night in flooded areas or when there's flooding going on is always incredibly dangerous, and we always urge folks not to drive around at night. And even driving around during the day during a flood can be extremely dangerous, and you never ever ever want to drive into floodwaters as you could get washed away and eventually drown as you get washed away downstream. And we did mention tropical systems can develop tornadoes and waterspouts. These are usually fairly isolated in nature. Some hurricanes, we don't see a whole lot of tornado activity, and then some hurricanes produce a ton of tornadoes. Hurricane Ivan in 2004 was a record-setting storm. It did come up into Virginia. It produced a large amount of tornadoes across Virginia and North Carolina as the storm system moved through. So these are things that we're tracking, these little quick circulations, and if we do see a tornado spinning up in a spiral band of a tropical storm or hurricane, we'll issue a tornado warning like we normally would if it was a thunderstorm. So we do see these little embedded tornadoes that do occur in hurricanes. We do track them and we issue warnings, and if we issue a tornado warning, your cell phone will alert you if you're in the area, let you know that we have issued a tornado warning. We did mention the rip currents earlier and waves, and again, this is just kind of a reminder that anytime a tropical system is passing offshore and it's generating waves, usually once the waves get over about 3 to 4 feet along the beaches, that's when the rip currents really start to increase and the surf starts to become a little bit more dangerous. It may not appear to be that dangerous and you may still be able to go swimming. You just have to recognize that the breaking waves can be dangerous, and then when you have those waves breaking, especially about 3 to 5 foot waves, those rip currents are actually increasing as well. We do forecast for the surf and the rip currents all summer long. So you can go to our website here, weather.gov/beach/AKQ. It's an interactive website, which is really nice. You can see the rip current threat along the coast. You can click on any one of those little umbrellas and get your local beach forecast, which includes your rip and surf forecast as well. So a great resource. We update this twice a day. The rip forecast and the surf zone and beach forecasts are updated twice a day. So always go in here, check out what's going on before you go to the beach, and just get an idea of not only the weather, but also the surf and the rip conditions. So some great resources that you can use to kind of track day-to-day weather as well as hurricanes throughout the year. The National Hurricane Center has a great website, nhc.noaa.gov. Check them out. They provide all the track information, the wind probabilities, where the hurricane is going to go, storm surge forecast from the National Hurricane Center. When you get down to trying to figure out what are the wind speeds going to be at your house, how much rain are we expecting, what's the storm surge going to be, what does the hurricane actually mean for me at my house or maybe where I'm evacuating to. So when you want those kind of forecasts, visit the Wakefield National Weather Service website. Weather.gov/AKQ is us. We do all the forecasts across most of Virginia, Maryland, and North Carolina. So go to our website, click on the map, and get your local forecast. We also, when we have our tropical system out there, we do have a special hurricane and tropical webpage. So if you go to weather.gov/AKQ/tropical, that will take you to our hurricane page that will combine not only the Hurricane Center's information, but also our forecast information as well. So it becomes like a one-stop shop for our local information of what we expect from the hurricane. Also, make sure you follow both the National Weather Service Wakefield and the National Hurricane Center on social media. We're both very active on both Facebook and Twitter. We post usually a couple times a day. Anytime there's active weather or a big storm, we're putting a lot of our forecast graphics and information out there, as well as useful websites. We post those on social media to help you keep up with what's going on.